Washington, D.C., August 1972. Inside the Department of Commerce building on Constitution Avenue, officials stamp approval on export license number 168. The document authorizes Bryant Grinder Corporation, a precision machine tool manufacturer based in Springfield, Vermont, to ship 168 ultra-precision grinding machines to the Soviet Union. The machines are destined for factories across the USSR, where Soviet officials claim they will manufacture micro ball bearings for electric motors in consumer appliances, vacuum cleaners, washing machines, household equipment. The official paperwork describes a straightforward commercial transaction between Cold War adversaries pursuing détente. But in offices across the Potomac River at the Pentagon, analysts are studying the same export license with growing alarm. They know something the Commerce Department appears to be ignoring. The Bryant grinding machines don't just make bearings for vacuum cleaners, they make bearings precise enough to guide nuclear missiles. This is the story of how the United States legally sold the Soviet Union the tools to improve their strategic weapons, wrapped in the fiction of household appliances. The Bryant Grinder Corporation had spent decades perfecting a specific type of manufacturing equipment. Their centerless grinding machines could produce spherical components with tolerances measured in millionths of an inch. This level of precision represented the absolute cutting edge of American manufacturing technology in the early 1970s. The machines worked through a process called centerless grinding, where a workpiece rotates between two grinding wheels without being mounted on a spindle or center. One wheel grinds the surface while the other regulates the rotation. The result is perfectly spherical components with surface finishes and dimensional accuracy that traditional machining methods cannot achieve. For micro ball bearings, this precision is essential. A ball bearing 1 millimeter in diameter must be spherical within tolerances of a few micrometers. Any deviation creates vibration, reduces efficiency, and shortens the bearing's operational life. Bryant's machines could hold these tolerances consistently across millions of bearings. By 1972, Bryant Grinder Corporation employed approximately 1,500 workers at their Springfield, Vermont facility. They manufactured grinding machines for aerospace companies, precision instrument makers, and defense contractors. Their customer list included firms producing components for the Minuteman missile program, military aircraft, and submarine systems. When Soviet trade representatives approached Bryant Grinder Corporation in 1971, they presented a compelling commercial opportunity. The USSR was expanding production of consumer goods as part of economic reforms aimed at improving living standards for Soviet citizens. Electric motors required high-quality ball bearings. Household appliances, power tools, and industrial equipment all depended on reliable bearings for their operation. The Soviet delegation explained that domestic bearing production couldn't meet the quality standards needed for modern consumer goods. Soviet-made bearings wore out quickly, caused excessive noise, and required frequent replacement. The Bryant machines would allow Soviet factories to produce bearings matching international quality standards, vacuum cleaners that ran quietly, washing machines that lasted years instead of months. The commercial logic appeared sound. The Soviet Union had substantial hard currency available from oil exports. Bryant Grinder Corporation would gain a major customer. American workers would benefit from the production and export of 168 complex machines. The transaction fit perfectly within the framework of détente, the policy of reduced Cold War tensions that President Richard Nixon and Secretary of State Henry Kissinger were actively promoting. The Department of Commerce evaluated the application according to standard procedures. Soviet end-use certificates stated the machines would be installed in civilian manufacturing facilities. The bearings would be used in consumer products, not military applications. In August 1972, the Commerce Department granted the export license. Bryant Grinder Corporation began preparing the machines for shipment. The first machines arrived in Soviet ports in late 1972, with subsequent deliveries continuing through 1973. The problem with the official story became apparent as soon as analysts at the Defense Intelligence Agency examined the specifications of the Bryant machines. Micro ball bearings used in household appliances typically range from 3 to 10 millimeters in diameter. Manufacturing tolerances for these applications are relatively loose, measured in tens of micrometers. A vacuum cleaner motor bearing can deviate from perfect sphericity by 20 or 30 micrometers without significantly affecting performance. The Bryant grinding machines being exported to the Soviet Union could hold tolerances of 2.5 micrometers or less. This represents precision roughly 10 times greater than necessary for consumer appliance bearings. Economically, this made no sense. Precision costs money. Tighter tolerances require more expensive grinding wheels, longer machine cycle times, more sophisticated quality control, and higher rejection rates. Manufacturing consumer appliance bearings on ultra-precision equipment is like using a surgical laser to cut plywood. But there's one application where 2.5 micrometer tolerances are not just useful, they're essential. Inertial guidance systems for ballistic missiles. An inertial guidance system allows a missile to navigate without external references. Gyroscopes measure rotation. Accelerometers measure linear acceleration. A computer integrates these measurements to calculate the missile's position, velocity, and orientation throughout its flight. For an intercontinental ballistic missile traveling 15,000 miles from launch site to target, the guidance system must maintain accuracy for 30 minutes of flight time while the missile experiences violent acceleration, vibration, and temperature changes. The gyroscopes that enable this precision depend entirely on ultra-precision ball bearings. The gyroscope rotor spins at tens of thousands of revolutions per minute. Any imbalance, any deviation from perfect sphericity in the bearings creates precession errors that accumulate throughout the flight. A bearing that's off by 10 micrometers can cause the missile to miss its target by miles. Soviet missile engineers had struggled with this problem since the 1950s. Their SS-9 and SS-11 intercontinental ballistic missiles deployed throughout the 1960s used relatively crude guidance systems with circular error probable measurements of 1 to 2 kilometers. For targeting hardened military installations like American missile silos, this accuracy was useless. By the early 1970s, the Soviet Union was developing a new generation of missiles with multiple independently targetable re-entry vehicles known as MIRVs. Each missile would carry multiple warheads, each aimed at a different target. This required guidance systems accurate enough to place individual warheads within hundreds of meters of their targets, not kilometers. The breakthrough required better gyroscopes, which required better ball bearings, which required better grinding machines. The Bryant machines, exported in 1972, could produce bearings meeting exactly these requirements. The Defense Intelligence Agency produced its first assessment of the Bryant export in late 1972, catalogued as Document ADA 104204. The analysis examined the technical specifications of the machines, the stated Soviet end use, and the military implications of the transfer. The assessment concluded that the precision capabilities of the Bryant machines far exceeded any reasonable requirement for consumer goods manufacturing. Analysts calculated that the economic cost of using such precise equipment for vacuum cleaner bearings would make Soviet appliances prohibitively expensive. The machine's capabilities aligned almost perfectly with the technical requirements for missile guidance system bearings. Intelligence analysts noted that Soviet factories producing gyroscopes for missile guidance systems had been identified as bottlenecks in Soviet strategic weapons production throughout the 1960s. The timing was particularly significant. In 1972, the Soviet Union was in the late development stages of the SS-18 Satan and SS-19 Stiletto ICBMs, both designed to carry MIRV warheads. These missiles would be deployed starting in 1974 and 1975. The guidance systems required for MIRV technology demanded precisely the kind of ultra-precision bearings that the Bryant machines could produce. The DIA assessment stated clearly that there was no convincing evidence that the machines were primarily used for civilian goods production. The report emphasized that while the machines might not have been decisive for the initial development of Soviet Mir-2 missiles, they probably eased production bottlenecks in precision components relevant to strategic weapons. This careful language reflected the intelligence community's standard caution, but the overwhelming technical and economic evidence suggested military application was the primary purpose. By 1973, members of Congress were receiving classified briefings about the Bryant export. The Senate Armed Services Committee, chaired by Senator John Stennis of Mississippi, began investigating how the Commerce Department had approved such a sensitive technology transfer. The hearings revealed a fundamental disconnect between the Commerce Department's export control procedures and the Defense Department's understanding of military technology. Commerce officials evaluated exports based on stated end use and official Soviet assurances. They had limited technical expertise to assess whether specific manufacturing equipment had military applications beyond what exporters claimed. Defense Department witnesses testified that the Bryant machines represented a clear military risk. They explained the technical requirements for missile guidance bearings and demonstrated how the machine's specifications matched those requirements almost exactly. Commerce Department officials defended their decision, arguing that they had followed all established procedures. The Soviet end-use certificates stated civilian application. Blocking the export would have contradicted the Nixon administration's policy of promoting détente through expanded trade. By 1975, the technical evidence of the Bryant machine's impact became clearer. The Soviet SS-18 Satan ICBM, first deployed in 1974, carried 10 MIRV warheads with a circular error probable of approximately 500 meters. This represented a dramatic improvement over previous Soviet missile accuracy. The SS-19 Stiletto, deployed in 1975, showed similar accuracy improvements. These accuracy gains came from better guidance systems, which required better gyroscopes, which required better ball bearings. The machines arrived in 1972 and 1973. The missiles with improved guidance accuracy were deployed in 1974 and 1975. The Bryant case became symbolic of broader problems with U.S. export control policy during the détente era. In 1979, Congress passed the Export Administration Act, which significantly tightened controls on dual-use technology exports. The legislation required enhanced Defense Department review of exports with potential military applications. The Reagan administration, which took office in 1981, made export control a central element of its strategy toward the Soviet Union and dramatically reduced technology exports to the Soviet bloc. The Bryant Grinder case raises questions that remain relevant decades later. In August 1972, when Commerce Department officials approved Export License 168, they were operating under assumptions that seemed reasonable within the framework of détente, but the technical reality contradicted these assumptions. The Bryant machines made bearings precise enough for missile guidance. The Soviets needed exactly this capability to deploy MIRV ICBMs. The official explanation about vacuum cleaners was implausible to anyone who understood the economics of precision manufacturing. The case demonstrates how political goals can override technical analysis. The United States helped the Soviet Union make vacuum cleaners, and both sides knew what the machines would actually produce.